We are going to start the second topic of module 4, which is nothing but definite integral using Gaussian quadrature. That means we can solve any definite integrals with the help of approximation created by Gaussian quadrature. Now you will say, okay, fine, definite, what do you mean by definite integral and why we need this? You will ask the question. Let us consider definite integration means you are going to integrate any function, okay, within the limit. Some limits will be there, that is known as lower limit and upper limit. So any integration of given function within the limit is known as definite integration. What do you mean by indefinite? Indefinite integration means you are going to integrate the function without given limits. But in case of definite integral, we will integrate that integration with given limits. Now, how it is going to help us? Gaussian quadrature. Let us consider your integration is -1 lower limit to upper limit is 1. We have considered the -1 to 1 fx dx. Now, sometimes it is very difficult to solve the integration in much easier way. That means if it is not possible to solve this definite integration, then there the Gaussian quadrature, we can apply the concept of Gaussian quadrature to solve this definite integration. Now what is that? What do you mean by it? The meaning is that any different definite integration you can represent in the form of summation. That means you can represent the integration in the form of summation and with some defined points from the lower to max higher value. Let us consider I can write the equation -1 to 1 fx dx is equals to summation y equals to 1 to n wi f of xi. Now see, first of all, the first question which came into my mind is that I need not to solve now integration. My problem was to solve -1 to 1 fx dx. But now this can be approximated in the form of summation. So I have written with the help of Gaussian quadrature approximation, this definite integration is equals to summation I equals to 1 to n and wi and f of xi. Now what is wi? It is a weighted function. Wi is nothing but weight, or in the simple way you can say coefficients, and that's all. So coefficients, wi is the coefficients of f of xi. That means in place of integration we need to solve the summation, which is very easy. To add the numbers is very easy. Just we are going to find the wi, that is the coefficients or weight of the given function f of xi at each point. So see, let us consider I can write I equals to 1, then it will be w1 f of x1 plus w2 f of x2, w3 plus f of x3, and so on, plus wn f of xn. Now see, w1 is constant term and f of x1 is also constant term, because f of x1 is nothing but the value at the particular point where x is equals to x1, the value of fx at x is equals to x1. So see, in place of finding the integration, we are finding the summation and we are adding some constant terms. This is known as the Gaussian quadrature. So what is the concept of Gaussian quadrature? It will approximate the given definite integration in the form of summation, and with the help of Python we can do it very easily in the form of integration to weighted sum. We call it as a weighted sum also. Now my dear friend, what is the command for that? It is very easy. Scipy dot integrate dot fixed underscore quad. Now quad means quadrature, which will help us to solve this. Now let us consider I wanted to solve this integration -1 to fx dx, and then I need not to solve this integration. I will go with the Gaussian quadrature rules, which will approximate this given integration into the summation wi f of xi. That means w1 f of x1 plus w2 f of x2 and so on. For some different defined points from I equals to 1 to n, and then we will get that. It is very easy. See, within one line I can solve. So from SciPy import integrate, because integrate we are using SciPy command here. We are not using NumPy here. SciPy, the Gaussian quadrature function quad has been defined, so I can use from SciPy import integrate. Then from import NumPy as NP, fine. Now define the function. Now let us consider my f of x is equals to x to the power 8. So I have defined the function x to the power 8, and then integrate dot fixed underscore quad, right? Because SciPy is already there, and from SciPy I mean importing the integrate. In that we can use the command integrate dot fixed underscore quad, define the name of the function and give the variable, that is till how many points you can consider. So, and you will get this integration value and easily. So inside how they are doing, we need not to worry about it. Just this integrate dot fixed underscore quad will approximate the given integration in the form of summation. And we need to define for how many points we are going to do it. So we have defined n equals to 4. So in this way, my dear friend, it is a very, very important concept to integrate the given definite integration with the help of the Gaussian quadrature. The integration which we cannot perform, we can use this equation to solve it. So this was the concept which we have used to solve given definite integration with the help of Gaussian quadrature. Thank you. Thank you.